So let's take a deeper look at the sphere techniques that I talked about. And the idea here is we want to fill this volume with spheres and then deform them. And what I'd like to do is I'd like to pick a specific frame where the character doesn't have a lot of intersections. Maybe here the hand, but overall I think this frame is fine. So I'm going to put down a time shift node and freeze the time at this frame. I'm going to convert it into an SDF. So VDB from polygon, and let's set this to turn on fill interior. And as you can see, we're not getting anything useful. That's because the geometry has openings. It's not watertight mesh. Even at a much smaller resolution, you can still see a lot of the issues here. And let's increase this back to 10. And quick way to fix this, or an attempt at fixing this, is using a polyfill. And I'm going to set it to triangles, and this will try to fill in the geometry as best as it can. So let's see how this works now. Cool. So now this is much better. It means it found a lot of openings, and this is much more stable now in Houdini 16.5, and this is actually new in Houdini 16, and now it has gotten much better. So this is the SDF with and without the polyfill. Okay, and let's go back one frame. I want to smooth this a bit, so I'm going to add a subdivide node and subdivide it. Okay, and let's lower this, maybe let's keep it to 0.1. I'm going to use a VDB to VDB spheres, VDB to spheres node. And 1 second. And let's take a look at the result. You can see we're getting a few spheres, and they're all inside this. They're all inside the geometry of Kong. And I'm going to turn on max radius. I'm going to set this to 2. And as you can see, a value of 2 only made that much spheres. Let's set it to 5. And for the max spheres, I'm going to increase this to 500. Okay, let's increase it to 5,000. And let's increase it to 10,000. So that's how much spheres. Actually, I think it can fit more. Yeah, so this is the sphere needed to fill out this entire volume. But what I don't like at the moment is that we have too many small spheres. So I'm going to lower the min radius to 0.03, and the max radius I'm going to set it to 10. Let's keep increasing this, and you see the higher the value, the bigger the spheres at the center are going to be. And I don't want this to be really high. I don't want to have too many spheres. Okay, so this is 3,000. And another thing that we could do to improve this result is tick on fill interior in the VDB from polygon. This generally helps provide more information for this node. And we're getting a decent result so far. Let me check one more thing. Min sphere, let's set this to 10. And let's increase this to 10,000. Yep, we're getting definitely a lot more spheres now. You see, even the small details now are filled. Let's see how many, 7,000. Let's increase the max radius to 30. So we get bigger spheres. And let's change the min to 0.1. I think these guys are too small for sure. Let's set this to 1. Stuff like this is not going to make a huge difference, and those are gone now. Yep, something like this. Cool. So this is our frame, and the way we're going to use this is we're going to treat it as an RBD object. Okay, so we're going to use an RBD object, an active RBD, a deforming RBD object, and we're going to use bullet, not the nodes that comes with bullet, not the static object. And let me check. Okay, so the next thing I'm going to do is we need to transform this, because right now we are generating it on one frame. So the way we're going to do that is using a point deform. And I'm going to deform these guys, and the rest points is this. Sorry, which one? Yeah, the mesh to deform is this. The rest points are this, and the rest point is this guy, and the deformed is here. I'll explain this in a second. Okay, so you can see now we are deforming those spheres with the geometry, but in some cases it's not doing a pretty good job. You know, these guys are. Let's template this geometry. Let's untemplate this. So you see, in some cases it's not working pretty well. So we have to find a good spot for. First, we can play with the settings here, which will help. But we can also change the frame we're generating the points at. So right now we're setting it to 8. We can pick a different frame, for example, where the arms are stretched further out, like this. Let's try frame 20 here. So that works here, great. And then in some other frames we're getting that. So we need a way, as you can see, I mean, there is a spot where we can find a way for this to work, but right now it's not. I don't think it's easy to figure this out. So what we're going to do is we're going to use something called the rest position. Okay, and this is something that every animation should have, which is the rest pose of the character. And this is going to be Kong at a T pose or a rest pose without very little deformation. So the arms will be stretched out, the legs will have no intersecting geometry, to say at least. And let me import that. I exported this as a different frame. Okay, so let's put down a alembic node. And this is the T-pose for the character. Okay. And instead of using frame 8 or a different frame, we're going to use this guy. We're going to use this frame to capture and generate the spheres, and then we're going to deform them. Now, how does the deform node work? The first input is what you want to deform, which is our spheres. Okay, we generated them at frame 20, and then we are deforming them. Now, the way the point deform figures out its binding is using point cloud, and this point cloud information comes from the third input, and we're telling it to use frame 8. Here, it's plugged into the third input. The second input is the rest, and this is our rest position. Okay, so this is use this frame to do the lookup and find the binding, and then the third is the deforming geometry, which is this. Okay, so instead of using this guy, we're simply going to use the rest pose, and I'm going to scale it because the scale is 10 times smaller, so I'm gonna set this to 10. Okay, and then I don't need the time shift. I'm gonna use this frame to generate the SDF polyfill it, and then convert this into spheres. Cool. And then we're going to use, this is going to be our static mesh, the rest pose. I don't need this anymore. So this geometry is the rest pose, and this is the deforming. Okay, so let's do one more thing here. It's a pack geometry, And when we did run it through the when we did run it through the VDB from Polygon, it converted it automatically. So I'm going to use an unpack node. Let's copy here. Let's copy these guys. Okay. VDB from spheres. And now everything should bind nicely. So let's see. Yep. See now how the spheres are staying inside the geometry. And there is no crazy jumping or anything like that. And the very important thing is that these spheres are not changing over time. So this point, for example, sphere number 1 is actually just transforming. Okay, and that's very nice because it helps with DOPs, it helps with the subframes and everything. So this is how we're going to do the collision for the geometry. Now I'm going to make this guy visible, and let's see where the wall is and where it is relative to Kong. Okay, so I'm going to scale the geometry here. This is just to test a few things. I've scaled it 10 times. I'm going to rotate this 180 degree. I should probably move Kong instead. Okay, let's do this. And now if I let's do it at this frame, sorry. So let's see. Cool. Let's move it a bit further and back. Okay, and I'm going to leave, I'm not going to change anything here. And let's go to Kong and create a null object. Call this out RBD Kong. And let's dive inside, and I'm going to create an RBD object. And I don't need that static stuff anymore. RBD object. This is Kong. We have a merge node and use deforming geometry. Okay, let's take a look. So that's the Kong geometry, and to check this, I'm going to go under Bullet tab, Show Geometry. And as you can see, it's still not working as expected. Okay, it's still generating this convex hull. The way to fix this is by changing it to compound. Okay, and now it's going to generate the collision for this geometry correctly. This is the mode that we need to set this to. Let's hide this. And I'm gonna lower, let's see how this looks. And that ground plane I'm gonna increase. And let's hit play. Okay, so it's not working. Let's lower the collision to 10. And the last node for this to work. And I wasn't sure if this is a viewport or not, but setting the compound mode only is not enough. We have to do one last thing, which is a bit weird, but we need to create a bake ODE node here. and this is going to add extra information for onto the geometry that helps Bullet figure out how it's gonna create the collision for these guys. And now if I say show collision geometry, it's gonna create an actual sphere for each of these guys. This is not packed primitives, just to be clear. This is different. This is an RBD object. And now go back. Let me hide the constraint network. And there we go. We have our constraint geometry working. We have collision working with a very high res geometry. And everything is working nicely. I mean, the fact that we have a stable sim already out of the box is a huge achievement. And Kong is actually moving really, really fast in terms of scene scale. And so far, nothing is exploding. And that's very cool. Okay, so the main idea here is the filling out the volume with spheres, okay, or the geometry of the spheres, and make sure that you can generate an SDF out of it to use the VDB from spheres. You need a rest pose with deforming geometry. If the animation department did not provide this, you have to have it. Okay, you have to have a state of the character where nothing is colliding with each other, generally a T-pose or rest pose. And then we generate the volume, we convert it into spheres. We try to set the settings so that we have enough spheres that covers the volume but not too small, so that we end up with so many of them. And then the point deform, that will deform these guys nicely. Okay, and these VDBs, these spheres are actually treated as points. Okay, that's why the point deform is working on them. They are not. They're treated as points, basically. They're not actual spheres with polygons on them. So that's why it's much easier. You can see the points already. If I display this, there's one at each centroid, and that's what's being used by the point deform node. And then the bake ODE there, and then here we use an RBD object, set this to use deforming geometry, and set it to compound, and everything is working. Let's increase this to 1,000, the constraint network to 1,000, and see how that looks. Cool. So if, for example, the leg was moving really fast, it is moving fast, but if we wanted to have better collision with that, it's not the bullet settings that's going to help. It's the DOP settings, and we have to make sure that we use a time blend node as well to make sure that the data provided have enough subsamples. So let's set this to 4. It's going to be 4 times slower. Sorry, I need to reset the cache. Now I need to dive inside. So it's going to be 4 times slower, and in this workshop I used a sample of 1 because I wanted to keep the sim time reasonable, and I was getting good results with that. But I highly recommend, if you have deforming geometry or something like this, to use a setting of 2 or higher. 2 to 4 is a good number. And you can see already here we're getting a much better impact, much better deformation happening. Now the other very, very important thing with this is that if we tweak the constraint settings, the strength and everything, using a DOP setting of 1, when we change it to 4, those settings, those constraint settings and breaking rules are not going to work, because the constraint now is being run 4 times. Okay, and instead of receiving, for example, a huge force at one time, it's receiving a lot of smaller forces every frame, every subframe. So it's doing more accurate collision and constraint solving with that, and we have to tweak the settings again. So you have to be very careful that setting, tweaking everything on a DOP setting of 1 is going to be very different from a setting of substep DOP 4. I think I said that right. Let me hide this guy. Yep, and this is a very basic constraint network. I mean, just a glue. We haven't done anything crazy yet. And I think that's pretty much it for this video and probably this week. Thank you guys for watching, and see you in the next one. Bye bye.